Hello, in this lecture we'll find out the value of x. In the drawing we have a quarter circle. AFE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, we know that this is line segment DE that is equals to 12 units in its length. This is angle GDC that is equal to theta. This is angle EDC that is also equals to theta. Our mission is to find out the length of this line segment GD is equal to x. Our mission is to find out the value of x. Okay, so first of all, ABCD is a square, and therefore all of its four angles are right angles. So this angle equal to 90 degrees in its side. This angle equals to 90 degrees. This angle equals to 90 degrees in its side. And this angle also equals to 90 degrees in its size. In addition, we know that the opposite sides of a square are parallel to each other. Again, the opposite sides of a square are parallel to each other. So in square ABCD, we know that side AB is parallel to side DC. So I write it down here, AB, side AB is parallel to side DC. But we know that AB is part of the straight line AE and it is parallel to DC. So if a part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. AB is parallel to DC, therefore the straight line AE itself must be also parallel to DC. So AB is parallel to DC. Here again, side AE, the straight line AE itself must be also parallel to DC. Okay. So here we have those two angles. They are defined as alternating angles, and they are located between the parallel lines DC and AE, and therefore they are equal to each other. Those two alternating angles, because of the fact that they are located between the parallel lines DC and AE, must be equal to each other. But this is angle EDC that is equal to theta, therefore this angle AED, must be also equal to theta. Okay, again, according to the rule that the alternating angles between parallel lines are equal to each other. Here I repeat again on rule 15. According to rule 15, alternating angles between parallel lines are equal to each other. So in the drawing we have two lines that are parallel to each other. This is line A that is parallel to line B, and those two angles are defined as alternating angles, and because of the fact that those two alternating angles are located between the parallel lines A and B, they must be equal to each other. That is to say, alpha equals to beta. Okay, and our drawing, those two alternating angles are located between the parallel lines DC and AE, and therefore they must be equal to each other. But this is angle theta, therefore this angle must be also equal to theta because of the fact that those two angles are equal to each other. Okay. So in the next step we will do a construction That is to say, from point G, we will draw perpendicular on AB. Again, from point G, we will draw perpendicular on AB. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB as N. Likewise, we define the intersection point of the perpendicular GN with side DC of the square as M. Actually, by doing this construction, we created here quadrilateral DMAN or DMNA. Inside this quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. Plus the size of this fourth angle, in total, they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside quadrilateral DMNA to 360 degrees, this missing fourth angle must be equal to 90 degrees. So inside quadrilateral DMNA we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral DMAN with 4 right angles as a rectangle. So I write it down here. Quadrilateral DMAN is a rectangle because it has 4 right angles. In the next step, we will focus on the left side of the perpendicular GN. GN is a perpendicular, it is absolutely a straight line. Again, GN is a perpendicular, it is absolutely a straight line. So if we focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle, that is a right angle. It is one out of 4 right angles of quadrilateral DMAN. And this is the missing angle, so the sum of those two angles, they must be equal to 180 degrees. Therefore, this missing angle, that is to say angle GMD, must be equal to 90 degrees in its side. Again, in order to complete the sum of the angles inside on the left side of the straight line GM at point, on the left side of the straight line GN at point M to 180 degrees, this missing angle must be equal to 90 degrees in its size. Okay, so here we have the right small triangle GDM. So I copy this right small triangle GDM in a new page and we will analyze it. The hypotenuse GD of the right triangle GDM equals to x according to what is given as the question. So actually, this is the right triangle GDM that I copied from the original drawing. This right triangle GDM, it is very easy to see that cosine theta equals to dm over dg. Again, cosine theta equals to dm over dg. So cosine theta equals to dm. dm is the missing side, so we leave it as it is, over dg. dg is x. So in conclusion, we found out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x. And finally, we get that according to equation 1, dm equals to x times cosine theta. So in the next step, I'll copy the right triangle ADE, this right triangle ADE in the new page, and we will analyze this right triangle ADE, but before that, we'll define one side of square ABCD as y, and therefore all the four sides of square ABCD must be equal to y. So AD equals to y, AB equals to y, CB equals to y, and finally DC also equals to y. So now I'll copy the right triangle AD in a new page and we'll analyze it. What is the definition of line segment AE or side AE? Side AE starts from the center of the quarter circle, that is to say from this point A, and ends at point E, that is a point on the quarter circle itself. This is exactly the definition of a radius. So we define the radius of this quarter circle as R, and therefore AE equals to R. It is the radius of the quarter circle. And side AD equals to y according to our definition. It is one side of square ABCD. Side DE equals to 12 units in its length according to what is given as the equation. So here the hypotenuse DE equals to 12. So in this right triangle ADE, and this is angle theta of course, this right triangle ADE, cosine theta, this will be equation 2, cosine theta equals to, this is point A, cosine theta equals to AE over DE. So cosine theta equals to AE is R over DE, that is 12. So cosine theta, according to equation 2, is equal to R over 12. This is according to equation 2. Well, according to equation 1, we already found out that dm equals to x times cosine theta. So now we can substitute cosine theta in this equation 1 by r over 12 from equation 2. We'll do it now, and we get that dm equals to x, and cosine theta is r over 12. So in conclusion, we found out that dm equals to xr over 12. Here dm equals to xr over 12. We have already found out that quadrilateral DMAN is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other, so a rectangle DMAN, side DM must be equal to the opposite side AN. But dm equals to xr over 12, therefore an must be also equal to xr over 12. Likewise, according to the same rule, in the same rectangle MDAN, side DA must be equal to the opposite side MN. Again, DA must be equal to MN, but DA equals to Y, therefore MN must be also equal to Y. In the next step, I'll copy again the right triangle DGM in your page, and we'll continue to analyze this right triangle DGM. So actually, this is the right triangle DGM, is the copy from the original drawing. In this right triangle DGM, it's very easy to see from the drawing that cosine theta and that sine theta equals to GM over GD. Again, cosine theta equals to GM over GD. So GM is the missing side, so we leave it as it is, over GD. GD is X, so we substitute GD by X. So in conclusion, we actually found out that according to equation 1, sinus theta equals to GM over X. Okay. In the next step, we multiply this equation 1 by x, and we get that according to equation 1, dm equals to x times sinus theta in the next step. I'll copy again the right triangle ADE in this new page, and we will continue to analyze this right triangle ADE. So actually, this is the right triangle ADE. It's a code from the original drawing. This right triangle ADE, sinus theta equals to AD over DE. So sinus theta equals to AD is R, so it's AD is Y, so we substitute AD by Y over DE. DE is 12. So according to equation 2, we actually found out that sinus theta equals to Y over 12. This is according to equation 2. While according to equation 1, we have already found out that Gm equals to x times sinus theta So now we can substitute sinus theta in this equation, equation 1, by y over 12 for equation 2. We'll do it now. We'll get that Gm equals to x, and sinus theta according to equation 2 is y over 12. So I shall find out that Gm equals to xy over 12. Gm equals to xy over 12. In the next step, we will join points A and G together by a straight line. What is the definition of line segment AG? Line segment AG starts from the center of the quarter circle, that is to say from this point, point A, and ends at point G, that is a point on the quarter circle itself. So this is exactly the definition of a radius. Therefore AG is the radius of this quarter circle, that is equal to R according to our definition. So actually, by joining points A and G, we created the right triangle AGN. So I'll copy this right triangle AGN in a new page, and we'll implement on this right triangle AGN the Pythagoras theorem. Here, by PT is the relation for Pythagoras theorem. The hypotenuse AG equals to R, it is the radius of the quarter circle. We already found out that AN equals to XR over 12. Finally, what is the length of side GN? From the drawing it is very easy to see that GN in total equals to GM plus MN. Again, GN equals to GM plus MN. GM is XY over 12 and MN is Y. So in total, GN equals to XY over 12 plus Y. Okay. Here, so I write it down. Here, GN equals to xy over 12 plus y. So here, this is the right triangle AGN that I copied from the original drawing. We just write down that the GN equals to xy over 12 plus y, AN equals to x over 12, and the hypotenuse AG equals to R. By PT is the evolution for Pythagoras theorem. According to the Pythagoras theorem in the right triangle AGN, G square equals to AN square plus GN square. It again, according to the Pythagoras theorem, in this right triangle AGN, AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is equals to XR over 12 square, and XR over 12 square equals to X square times R square over 12 square, that is 144, plus GN square. GN is XY over 12 plus Y, and therefore GN square is XY over 12 plus Y square. So according to equation 1, R square equals to X square times R square over 144. And here this expression, actually we will take Y as a common factor out of this expression. So Y is taken as a common factor. So what is left from xy over 12 factor 2 from it, Y is a common factor. What is left is actually x over 12 plus y. What is left from y after we took from it y is a common factor? What is left is actually 1. All to the power of 2 of the expression. So in the next step, we'll open one pair of brackets of this expression, and we get that according to this equation, equation 1, r square equals to x square times r square over 144 plus, here somebody mentioned before, we'll open one pair of brackets. After we open the brackets, we'll have here y square, and this expression will be also to the power of 2 square. Actually, according to the algebraic identity, that a times b to the power of m is equals to a to the power of m times b to the power of m. According to this algebraic identity, after we open the brackets, we get y square times x over 12 plus 1 squared. Here, y square times x over 12 plus 1 squared. Here we multiply 1 by 12 and then we divide it by 12 in order to have a common factor with x over 12. And we get that according to equation 1, r square equals to x square times r square over 144 plus y square. So here after we multiply 1 by 12, so in the numerator we have in total x plus 12 divided by 12 square. Repeat again. So we took 12 as a common factor from this expression. we get that this expression will be equal to x plus 12 over 12 squared. Okay, now, so we have here x over 12 over 12 squared. Here we have another algebraic identity. Here the algebraic identity that a over b to the power of m equals to a to the power of m over b to the power of m. According to this algebraic identity, we get that this expression x plus 12 over 12 squared will be equal to x plus 12 squared over 12 squared, that is actually 144, multiplied by y squared plus x squared times r squared over 144, and it is equal to r squared according to equation 1. Okay, in the next step we'll join points A and C together by straight line, those 2 points, and after we join points A and C, so first of all, what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and ends at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that's equal to R according to our definition. So now, by doing this construction, actually we created the right triangle ABC. So I copied this right triangle ABC in a new page, and we will implement on this right triangle ABC the Pythagoras theorem. So you can see for the drawing, side AB equals to y and side BC also equals to y. They are both the sides of square ABCD, and you know that the sides of any square are equal to each other. Each side is equal to y, therefore all the 4 sides of square ABCD, they are equal to y. So I repeat again that by PT is the relation for Pythagoras theorem. Repeat again in Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse AC equals to R, AB equals to Y, and BC equals to Y. So actually, this is the right triangle ABC that I go from the original drawing. According to the Pythagoras theorem, in this right triangle ABC, AC square, this will be equation 2, AC square equals to AB square plus BC square. Again, in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square. is equals to AB square. AB is y, therefore AB square is y square, plus BC square. BC is also y, therefore BC square is y square. In conclusion, we can find out that r square equals to y square plus y square. So according to equation 2, r square equals to 2y square. This is according to equation 2. While according to equation 1, we have already found out that r square, here this is equation 1, r square equals to x square times r square over 144 plus y square times x plus 12 square divided by 144. Okay, so those are the two questions that we have here. So now we can substitute r square in this equation, equation 1, by 2y square from equation 2. We'll do it now, and we get that according to equation 1, r square is 2y square, and it is equals to x square, again r times r square, and r square is 2y square according to equation 2, divided by 144 plus y square times x plus 12 square divided by 144. So here we will divide this equation 1 by y square, and we get that according to equation 1, two y square over y square is 2, and it is equals to, here y square will get cancelled, and we left only with 2x square over 144 plus, here y square also will get cancelled, and we left only with x plus 12 square over 144. So here we will multiply this equation 1 by 144, and we get that according to equation 1, 2 times 144 is 288, and is equals to, here we have 144 in the denominator, so 144 will get cancelled, and we left only with 2x squared plus, here we have 144 in this equation, this expression in the denominator, so 144 also will get cancelled, and we left only with x plus 12 squared. So according to equation 1, we actually found out that 288 equals to 2x squared plus x plus 12 squared. So here we open the brackets, this expression, and we get that according to equation 1, 288 equals to 2x squared plus x plus 12 squared equals to x squared plus 12 squared, that is 144, plus 2 times x times 12, that is 24x. So I finally found out that according to equation 1, 288 equals to 2x squared plus x squared is 3x squared plus 24x plus 144. Here we subtract 288 from this equation, question 1, and we get that according to equation 1, in this side of the equation we have left with nothing, that is to say 0, and it equals to 3x squared plus 24x, and here we have 144 minus 288 equals to minus 144. So here we divide this quadratic equation by 3, and we get that according to this equation, equation 1, three x squared over 3 is x squared, plus 24x over 3 is 8x, minus 144 over 3 is minus 48, that equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and finally the coefficient c equals to minus 48. So now we'll put the values of a, b, and c that we found for our specific quadratic equation, this equation, in this general formula for x in order to find out the value or the values of x in our specific quadratic equation. I want to you that x is the variable that we're looking for in this question. X is actually the length of 97 GD. Okay, so we'll put the values of a, b, and c, those values for our specific quadratic equation in this general formula in order to find out the value or the values of x for our specific quadratic equation. So we'll do it now, and we get that x equals to minus b. b is 8, therefore minus b is minus 8, plus minus square root of b squared. b is 8, therefore b squared is 8 squared, that is 64, minus 4 times a is 1, so minus 4 times 1 is minus 4, times c. c is minus 48, therefore minus 4 times minus 48 is plus 192 divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So I found out that x equals to minus 8 plus minus, inside the root we have 64 plus 192 is 256, so we left only with 256 inside the root divided by 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 divided by 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So if I found out that x equals to minus 12, but because of the fact that x is a length, it's a length of line 7GD, x as a length, it must be a positive number. It can never be equal to any negative number. Therefore, this solution is the correct solution. We cancel the solution and we take into account only the positive solution for x. And the positive solution for x is that x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. X equals to 4 units. So if I found out that the length of this line 7GD that is equal to x according to what is given as the question is equals to 4 units. Again, GD, the length of line 7GD that is equal to x equals to 4 units. So that is the answer to the question. So in the next step I will summarize the lecture. In this lecture, we found out the length of this line 7GD that is equal to x. So in the drawing we have a quarter circle, FAE is a quarter circle. Inside this quarter circle we have square ABCD. In addition, you know that this is line 7DE that is equal to 12 units in its length. This is angle theta, this is angle GDC that is equal to theta. This is angle EDC that is also equal to theta. And our mission is to find out the length of this line 7GD that is equal to x according to what is given as the equation. We have to find out the value of x. So first of all, we know that all the four sides, all the four angles inside square ABCD are right angles. So those four angles, they are right angles. In addition, we actually know that the opposite sides of a square are parallel to each other. And especially it is true in square ABCD. In square ABCD, side DC is parallel to opposite side AB. Again, side DC is parallel to the opposite side AB in square ABCD. But we know that AB is part of the straight line AE and is parallel to DC. If part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the other straight line. So if AB is parallel to DC, then the straight line AE itself must be also parallel to DC. And AE is parallel to DC. So we have here those two angles are defined as alternating angles, and they are located between the parallel lines DC and AE. Again, we just found out that DC is parallel to AE. And because of the fact that those two alternating angles are located between the parallel lines DC and AE, they must be equal to each other, according to the rule that alternating angles between parallel lines are equal to each other. According to rule 15, this is rule 15. We have here line A is parallel to line B, and angles alpha and beta, they are defined as alternating angles, and they are located between the parallel lines A and B, and therefore they are equal to each other. That is to say, alpha equals to beta. Therefore, those two alternating angles that are located between the parallel lines AE and DC must be also equal to each other. But this is angle theta according to what is given as the question. Therefore, this angle must be also equal to theta because of the fact that those two angles are equal to each other. So this angle equals to theta. So in the next step we did the construction. That is to say, from point G we go perpendicular on AB. Again, from point G we go perpendicular on AB. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point G and AB is N. Likewise, we defined the intersection point of perpendicular GN with side DC of the square as M. By doing this construction, we created quadrilateral DMNA. This is quadrilateral DMNA. Inside this quadrilateral DMNA, we have 1, 2, 3 right angles, and therefore this fourth missing angle must be equal to 90 degrees in its size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So inside this quadrilateral DMNA, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral DMAN that has 4 right angles as a rectangle. Here, this quadrilateral is a rectangle. So we know that GN is perpendicular. GN is a perpendicular, it is absolutely a straight line. So if we focus on the left side of the straight line GN at point M, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of GN at point M? We have this angle that is equal to 90 degrees. This is 1 out of 4 angles of quadrilateral DMAN. This is equal to 90 degrees in size. So this angle, that is the right angle, plus this missing angle, in total those two angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. So this missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the left side of the straight line GM, in the left side of the straight line GN at point M to 180 degrees, this missing angle must be equal to 90 degrees in its size. And therefore, triangle GMD is a right triangle. So I copy this right triangle GMD in a new page and analyze this right triangle GMD. So actually, this is right triangle GMD that I copied from the original drawing. In this right triangle GMD, it is very easy to see that cosine theta equals to dm over gd. dm over dg or gd. So dm is the missing side, so we leave it as it is, over dg. dg is x, therefore substitute dg by x. So in conclusion, we found out that according to equation 1, cosine theta equals to dm over x. Here we multiply this equation 1 by x, and finally found out that according to equation 1, dm equals to x times cosine theta. In the next step, I copied this right triangle ADE in the new page. We analyzed this right triangle ADE, but before that, we defined one side of square ABCD as y, and therefore all the 4 sides of this square ABCD must be equal to y, of course. AD is y, AB is y, BC is y, DC is also y. And AE, what is the definition of line segment AE? Line segment AE starts from point A, that is the center of the quarter circle, and ends at point E, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AE is the radius of this quarter circle is equal to R according to our definition. And it is given us the equation that D equals 12 units in itself. So this is the right angle ADE, the copy from the original drawing. In this right angle ADE, it is very easy to see that cosine theta equals to AE over DE. Again, cosine theta equals to AE over DE. AE is R, DE is 12, so in total cosine theta equals to R over 12. Again, according to equation 2, cosine theta equals to R over 12. This is according to equation 2, while according to equation 1, we have already found out that dm equals to x times cosine theta. Okay, according to equation 1, dm equals to x times cosine theta. Now we can substitute cosine theta in this equation, equation 1, by R over 12 for equation 2. Okay, we already found out that cosine theta according to equation 2 equals to R over 12. You can substitute now cosine theta in this equation, equation 1, by R over 12 from equation 2. We did it and found out actually that dm equals to x times cosine theta. Cosine theta equals to R over 12. So in total we actually found out that dm equals to xr over 12. So this is side dm. This is equal to xr over 12. We already found out that this quadrilateral DMNA is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. So in rectangle DMNA, side DM must be equal to the opposite side AN. But DM is XR over 12, therefore AN must be also equal to XR over 12. Likewise, according to the same rule, that the opposite sides of a rectangle are equal to each other, in rectangle DMAN, side DA must be equal to the opposite side MN. Again, side DA must be equal to the opposite side MN in rectangle DMNA. But DA equals to Y, therefore MN must be also equal to Y because of the fact that those two sides are equal to each other. Okay. In the next step, I copy it again, right, this right small triangle DGM. In the page, we continue to analyze this small right triangle DGM. So actually, this is the right triangle DGM that I copied from the original drawing. In this right triangle DGM, it is very easy to see that sinus theta equals to GM over GD. Sinus theta equals to GM over GD. GM is the missing side, so we leave it as it is over GD. GD is x, therefore we substitute GG by x. So in conclusion, we found out that according to equation 1, sinus theta equals to GM over x. We multiply this equation 1 by x, and finally found out that GM equals to x times sinus theta. This is according to equation 1. In the next step, I copied the right triangle ADE in this new page here, and we analyze this, continue to analyze this right triangle ADE. In this right triangle ADE, it is very easy to see that sinus theta equals to AD over DE. Again, sinus theta equals to AD over DE. AD is y, DE is 12, so in total sinus theta equals to y over 12. Repeat again, that according to equation 2, we just right now found out that sinus theta equals to 1 over 12. This is according to equation 2, while according to equation 1, we have already found out that GM equals to x times sinus theta. Yeah, GM equals to x times sinus theta. So actually, we can substitute sinus theta in this equation 1 by y over 12 from equation 2. We did it and found out that GM equals to x and sinus theta is y over 12, and therefore in total GM equals to xy over 12. Here, this side GM equals to xy over 12. So in the next step, we'll join points A and G together by a straight line. What is the definition of line segment AG? Line segment AG starts from point A, that is the center of the quarter circle, and ends at point G, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AG is the radius of this quarter circle that is equal to R according to our definition. By joining points A and G together by a straight line, we created the right triangle AGN. So I copied this right triangle AGN in a new page and we implemented the Pythagoras theorem on this right triangle AGN. This is the right triangle AGN that I copied from the original drawing. We just right now found out that the hypotenuse AG equals to R. It is also the radius of the quarter circle. We have already found out that AN equals to XR over 12. And finally, what is the definition of line segment GN? On side GN, GN actually equals to GM plus MN. Again, GN equals to GM plus MN. So GN equals to GM, that is XY over 12, plus MN, that is Y. So in total, GN equals to XY over 12 plus Y. And again, GN equals to XY over 12 plus Y. AN equals to XR over 12, and the hypotenuse AC equals to R. It is the radius of the quarter circle. So according to the Pythagoras theorem, in this right triangle AGN, AG square equals to AN square plus GN square. Again, AG square equals to AN square plus GN square. AG is R, therefore AG square is R square, and it is equals to AN square. AN is XR over 12, therefore AN square is XR over 12 square. XR over 12 square equals to X square times R square over 12 square, that is 144. So in total, XR over 12 square equals to X square times R square, X square times R square over 144 plus GN square. GN equals to XY over 12 plus Y, therefore GN square will be equal to XY over 12 plus Y square. So here we took Y as a common factor from this expression and actually found out that according to this equation, equation 1, R square equals to X square times R square over 144. Here, repeat again that we took Y as a common factor from this expression. So what is left from xy over 12 after we took from it y as a common factor? What is left is actually x over 12, and what is left from y after we took from it y as a common factor? What is left is actually 1 squared. Here we opened one pair of brackets in this expression, and according to the algebraic identity that a times b to the power of m equals to a to the power of m times b to the power of m, we get that here, this after we open the brackets here we get that this expression will be equal to y squared times x over 12 plus 1 squared. Again, it is equal to y squared times x over 12 plus 1 squared. And then here I copied here this expression x squared over r squared, x squared times r squared over 144, and it is equal to r squared according to this equation, equation 1. Here I multiplied 1 by 12 and then we divided by 12 in order to account factor with x over 12. So after we took 12 as a common factor from this expression, in total in the numerator we have x plus 12, in the denominator we have 12. So actually I found out that this expression will be equal to x plus 12 over 12 squared. Okay. So it is x plus 12 over 12 squared times y squared plus x squared times r squared over 144. This is equal to r squared. This is according to equation 1. And here we have r squared equals to x squared times r squared over 144. And this expression, x plus 12 over 12 squared, according to this algebraic identity that a over b to the power of m equals to a to the power of m over b to the power of m, and we get that this expression, x plus 12 over 12 square will be equal to x plus 12 square over 12 square. X plus 12 square over 12 square, and 12 square is 144. So this expression in total will be equal to x plus 12 square over 144 times y square plus x square times r square over 144. This is equal to r square. This is according to equation 1. In the next step, we join points A and C together by a straight line. By joining points A and C, we can, but before that, what is the definition of line segment AC? Line segment AC starts from point A, that is the center of the quarter circle, and that is the center of the quarter circle, and ends at point C, that is the point of the quarter circle itself. So this is exactly the definition of a radius. Therefore, AC is the radius of this quarter circle, that is equal to R according to our definition. So by joining points in together by straight line, we created the right triangle, triangle ABC. So I copied this right triangle, triangle ABC in your page and implemented the Pythagoras theorem in this right triangle, triangle ABC. This is the right triangle ABC that I copied from the original drawing. We just right now found out that the hypotenuse AC equals to R. This is the radius of the quarter circle. AB and BC, they are both the sides of square ABCD, and therefore they are equal to Y according to our definition. So in this right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. But again, according to the Pythagoras theorem, in this right triangle, triangle ABC, AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, AB is Y, therefore AB square is Y square, and BC is also Y, therefore BC square is Y square. So actually in total, according to equation 2, we found out that R square equals to Y square plus Y square. So R square equals to Y square, according to equation 2, while according to equation 1, we already found out that R square equals to X square times R square over 144 plus Y square times X plus 12 square over 144. So we have here two equations. Now we can actually substitute R square in this equation, equation 1, by 2Y square from equation 2. We did it, and we got that R square is 2Y square, according to equation 1, and it is equal to X square, and X square times X square times R square. And again, R square is 2Y square over 144 plus Y square times X plus 12 square over 144. So here we divided this equation 1 by Y square, and found out that according to equation 1, 2Y square over Y square is 2. And here, in the other side of the equation, we divided the other side of the equation by Y square. So Y square we get cancelled this expression, and we left only with 2x square over 144 plus here. In this expression, Y square will also get cancelled, and we left only with x plus 12 square over 144. Here we multiply this equation 1 by 144, and finally found out that according to this equation 1, 2 times 144 is 288. That equals to here 144, the denominator 144 will get cancelled, and we left only with 2x square. Here also the denominator 144 will get cancelled, and we left only with x plus 12 square. So I found out actually that according to this equation 1, 288 equals to 2x square, and here we open the brackets of this expression, and x plus 12 square equals to x square plus 12 square, that is 144, plus 2 times x times 12, that is 24x. So according to equation 1, we have 288. That equals to 2x square plus x square is 3x square plus 24x plus 144. So here we subtracted 288 from this equation 1, and finally found out that in this side of the equation we left with nothing, that is to say 0. That equals to 3x square plus 24x, and 144 minus 288 is minus 144. So actually according to equation 1, we found out that 0 equals to 3x square plus 24x minus 144. Here we divided this equation 1 by 3, and finally found out actually that 3x squared over 3 is x squared, 24x over 3 is 8x, minus 144 over 3 is minus 48. So actually, I found out that x squared plus 8x minus 48 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 8x minus 48 equals to 0, the coefficient a equals to 1, the coefficient b equals to 8, and the coefficient c equals to minus 48. So now we have to put these values for a, b, and c in this general formula for x in order to find out the value or the values of x for our specific quadratic equation. X squared plus 8x minus 48 equals to 0. I remind you that x in our specific quadratic equation is the variable that we are looking for. X is the rank of this line 7, GD. So actually put the values of a, b, and c that we found for our specific quadratic equation in this general formula for x in order to find out the value of x in our specific quadratic equation. So we did it here and found out actually that x equals to minus b. B is 8, therefore minus b is minus 8 plus minus square root of b squared. Again, b is 8, therefore b squared is 8 squared, that is 64. Minus 4 times a is 1, so minus 4 times 1 is minus 4, times c, that is minus 48. So minus 4 times minus 48 is plus 192 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So x equals to minus 8 plus minus, inside the root we have 64 plus 192, that is 256, divided by 2. So x equals to minus 8 plus minus, and the square root of 256 is 16 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 8 minus 16 over 2. Minus 8 minus 16 is minus 24, and minus 24 over 2 is minus 12. So according to the first solution for x, x equals to minus 12. But x can never be equal to minus 12. Why? Because x is the length of line 7 GD, and x is a length, and it must be a positive number. Therefore x can never be equal to minus 12, that is a negative number. So we cancel this solution, we took into account only the positive solution for x. And the positive solution for x is that x equals to minus 8 plus 16 over 2. Minus 8 plus 16 is 8, and 8 over 2 is 4. So actually we found out that x equals to 4 units in its length. 9/7 GD is equal to x is equal to 4 units in its length. Okay, thank you very much.